The James Webb Telescope has once again shown itself to be humankind's strongest tool for uncovering the universe's secrets. With infrared abilities far more advanced than any that have come before, Webb has now spotted a super-Earth that is extremely habitable, positioned just 40 light-years away in the TRAPPIST-1 system. The super-Earth, bigger than our own planet but smaller than gas giants such as Neptune, is in the habitable zone of its star with conditions apparently favorable to liquid water and even life. It is a colossal discovery. It provokes deep questions. Could there be life on this alien planet? And if so, what would it be like? But what is so remarkable about a super-Earth? Such planets, which are usually rocky and as much as 10 times the Earth's mass, hold a special place in the classification of planetary bodies. Having greater gravity and thicker atmospheres, they might support environments supportive of life in the form that we know or even life we cannot yet envision. The James Webb Telescope's sophisticated spectroscopy instruments picked up water vapor, methane, and hints of oxygen in the atmosphere of this super-Earth. These are essential ingredients for life, making this planet one of the most promising ever discovered. This discovery not only suggests a living ecosystem but also redefines our understanding of how planets form and support life. TRAPPIST-1 is a highly cooled dwarf star that has 7 terrestrial planets, 3 of which orbit within the habitable zone. This system has intrigued scientists for many years, and now the super-Earth is the prized asset of its findings. The cool temperature of the star gives a stable climate, minimizing the dangers of intense radiation. Nevertheless, being close to TRAPPIST-1 results in tidal locking where one side constantly faces the star while the other side is continuously in darkness. Even with these obstacles, the thick atmosphere of the super-Earth might be what stabilizes temperatures, producing a balance that might be life-friendly in ways we have yet to realize. The most thrilling part of the discovery is the identification of possible biosignatures, chemical signatures in the atmosphere that suggest the presence of life. Molecules such as methane, oxygen, and carbon dioxide have been discovered in strange proportions, which might indicate biological processes are involved. These observations are consistent with conditions on Earth, where similar molecules are synthesized by living systems. Although the signals might be explained by geology, their potential for its harmfulness to life has brought a tidal wave of excitement in the scientific community and among people in general. This finding takes us closer than ever before to solving the centuries-old question: are we alone in the universe? Water is sometimes referred to as the essence of life, and its presence is a major sign of habitability. The James Webb Space Telescope's examination of the super-Earth's atmosphere showed strong evidence of water vapor, leaving the tantalizing prospect of liquid water on its surface. The presence of water vapor indicates that the planet could have a stable hydrosphere, possibly with enormous oceans. These oceans, aided by the proper atmospheric pressure and temperature, might be the ideal setting for microbial life, or even something more sophisticated. Even more interesting is the potential for surface water reservoirs. If the surface is not welcoming due to temperatures at extremes, life might find a home in underground aquifers, similar to extremophiles on our own planet. While this super-Earth holds tantalizing prospects, its tidal locking holds special challenges to habitability. With one half of the planet constantly facing its star and the other in constant darkness, there could be zones of extreme climate. But researchers speculate that the dense atmosphere of the planet might serve as a thermostat, distributing heat from the side of the planet facing the sun to the dark side. This might establish a temperature band along the terminator, the boundary between day and night, providing a refuge for life. Light and darkness may interact to fuel unusual evolutionary developments, leading to life as distinct from anything on our planet. The discovery of the super-Earth wouldn't have been possible without the technological marvel that is the James Webb Telescope. Its ability to analyze the faintest signals from distant worlds has revolutionized our understanding of exoplanets. Using infrared spectroscopy, Webb detected the chemical fingerprints of the super-Earth's atmosphere, identifying key molecules that suggest habitability. This advance is only the start, however, as the next telescopes and missions will use Webb's discoveries as a foundation to look at this planet in even greater detail. Advances in technology at a lightning pace are moving us closer and closer to providing one of the most profound answers for humanity. Are we alone? The find has created a new generation of interest in interstellar travel. Although the planet is 40 light-years from Earth, too far for any spacecraft to travel, the ideas of light sails and nuclear propulsion are being considered to span the gap. At the same time, efforts on Earth are gaining steam. Researchers are applying machine learning to reinterpret data from the James Webb Telescope, revealing new information about the planet's atmosphere, surface conditions, and possible biosignatures. This finding has also reawakened the public interest in space exploration, with more funds for exoplanet missions and a renewed mission to reach for the stars. With the identification of atmospheric signs of this super-Earth, researchers now turn their attention to determining biosignatures, important chemical indicators that would tell them whether life exists. Molecules like oxygen, methane, and nitrous oxide are closely watched, as their presence at the correct mixtures may be indicative of biological processes. The James Webb Telescope has already picked up methane and carbon dioxide, but now scientists are searching for changes in these gases over time. Seasonal or unanticipated fluctuations would be indicative of active life, similar to the seasonal fluctuations we see in Earth's biosphere. These discoveries are not conclusive evidence, but they add another layer of interest to this already intriguing discovery, motivating attempts to collect even more information. Perhaps the most exhilarating part of this discovery is the prospect of what life on this super-Earth might be. Due to its unusual setting, high gravity, thick atmosphere, and possible oceans, life itself would likely develop in new and unprecedented ways. Some scientists speculate that life on this world might consist of microbes that live in surface oceans shielded from the radiation. Others hypothesize about more sophisticated ecosystems in which life has evolved to meet the special conditions of the planet over billions of years. These simulations are not fantasy exercises. Rather, they are based on the evidence gathered by Webb and give insight into the possibility of life elsewhere in the universe. As the habitability evidence mounts, a question then presents itself: what should human society do if we find evidence of intelligent life? The discovery of the super-Earth has brought back debates about whether we should try to contact extraterrestrial civilizations. Some argue that contact with an advanced civilization can hasten our technological advancement and answer what science has long sought but not found. Others, such as well-known physicist Michio Kaku, warn us not to alert beings to our existence who could view us as threats or use us as a resource. The discoveries of the James Webb Telescope thrust this argument into the limelight, compelling humanity to confront the ethical and existential ramifications of its position within the universe. This super-Earth's discovery is not only a milestone but a launchpad for the future of humanity in space. With every accumulation of data, the imperative to